Hello, welcome to Einstein's Mechanics. In today's episode, we are going to look at the part 2 of the method of separation of variables in solving a differential equation. So let's take some few examples and see how best we can do it. So let's solve this equation. So solve the differential equation, and this is our equation: 2xy plus 2y dx minus y dy is equal to 0. So we are to solve this equation with the method of separation of variables. So what do we do? Now we have to write down our equation. So our equation is going to be, we have 2xy plus 2y dx minus y dy is equal to 0. So we have to separate them, leaving the y on the one side of the equation and the x on the other side of the equation. So with this, we can do factorization here by factorizing 2y out. Then we are left with x plus 1 dx minus y dy this way is equal to 0. So what can we do? We have to now move all the y. So here we can leave our x plus 1 with the x equal to, we transfer y dy to the other side of the equation and divide both sides by 2y. This is what we are going to get. How we go. So finally, this is what we are having. The integral of x plus 1 dx is equal to, with this y will cancel out this y, leaving us integral of 1 on 2 dy. So if we apply our integration, then we are going to have x squared on 2 plus 1 equal to, now the integral of half is going to be 1 half, 1 on 2 of what? Y plus c. If we want to get rid of the fraction, we can multiply through by 2, getting x squared plus. Now, this is going to also give us x over here. Yes, if we integrate this one, we are getting x. So that is multiplying through by 2x squared plus what? 2x. Right. We are going to get x squared plus 2x is equal to y plus, say, 2c. But 2c is also a constant. No matter what we have, the 2c is a constant. So we can finally write it as x squared plus 2x equal to y plus c. So this c1 is going to represent the constant 2c. If we are making y the subject, then our equation is going to be y equal to what? X squared plus 2x plus c1. So this will be our final equation for the differential equation. This is the solution. Are you okay? The solution to the differential equation. Now let's take another example and see how best we can solve that. Now let's go to question 2. Now let's solve the differential equation. So solve the differential equation. This is our equation: xy dy minus 1 plus y squared on 1 plus x squared dx is equal to 0. So we are to solve this problem, and we want to use the method of separation of variables. So what can we do? We have to first rewrite our equation again, and this is our equation: xy dy minus 1 plus y squared on 1 plus x squared, everything by what? Dx. That is equal to 0. I want to do the separation by getting the y on one side and the x on the other side. So this is what I'm going to get. I'm trying to have x y dy equal to 1 plus y square on 1 plus x square dx on the other side of the equation. Are you okay? Now, we are not done yet, right? We still have y over here and we have x over here. So I can divide both sides by x and also divide both sides by 1 plus y squared. So at the end of the day, I'm going to get this as my y on 1 plus y squared dy equal to, I'm also going to have 1 on x multiplying 1 plus x squared for the dx. This is the separation after grouping the x and the y on the other side of the equation. I'm going to apply my integration to y on 1 plus y squared and also apply integration to 1 on x 1 plus x squared or dx. So let's take them one by one. I would like to take the integration on the left hand side. So here at the left hand side, I'm getting my integration to be integral of y on 1 plus y squared dy. So I'm going to integrate this. Remember, if you have this integration where we are going to have integral of f prime of x over integral of what? F of x. This is going to be, the answer is going to be the natural log of what? F of x, right? So anytime you have an integration where the numerator is the derivative of the denominator, then the answer is going to be natural log of what? The denominator. So same thing is happening here. We can see that when we differentiate the denominator, we are going to get something like what? Only if I differentiate only 1 plus y squared, the derivative is going to be 2 what? Y. So when we look at the numerator, the upper side, we are only having the y. So we want a way such that we will get the 2y, making the derivative of the denominator equal to the numerator. So what I'll do is I'll multiply both sides of the division by what? 2. So I'll say 2 on 2. Remember, this will cancel out, making 1. Making what? Integral of y on 1 plus y squared dy. So I've not done anything to the equation. I am just multiplying both sides by 2. So this is the same as 1 on 2 integral of this 2 will come inside 2y on 1 plus y squared. So now with this, we can see that when we differentiate the denominator, we are going to get 2y over here. Are we okay? So at the end of the day, our derivative or our integration of this equation is going to be half the natural log of the denominator, which is 1 plus y squared. This is the answer for the left hand side integration. Are we okay? Now let's look at the right hand side. What are we getting? So at the right hand side, look at our integration. Our integration is of the form 1 on x 1 plus x squared dx. We can only integrate this using partial fraction. This is integration by partial fraction. So first we can express them as a on the first part x plus bx plus c. You can refer to my previous videos on calculus, how to integrate partial fractions. So bx plus c, 1 plus x squared. So now we have to find the value of a, b, and what? And c to be able to solve this equation. So let's look at how we are going to find the values. Now, this is where we are. We have something like a on x plus bx plus c on 1 plus x squared equal to integral of 1 on x 1 plus x squared. This is what we have. So if we are solving by partial fraction and we are going to find the values of a, b, and c, this is what we are going to do. We are going to equate the numerator to the left hand side. So we are going to get 1 is equal to, now if we are going to add this, it is going to change for this way. The a is going to take the 1 plus x squared plus bx plus c is going to multiply the x. We want to find the value of a and b when x is equal to 0. When you put x equal to 0 into the equation, you are going to get a is equal to 1. The same way, when you put x equal to 1 into the equation, you are going to get 1 is equal to, now 1 will be here. That is going to be a 1 plus 1 square, like this, plus b multiplying 1 plus c by 1 this way. Very good. So at the end of the day, we are going to get this equation as b plus c is equal to minus 1. First equation. Now we want to solve b and c, so we have to get two equations for two unknown. So we are going to set when x is equal to 2, we are also going to put it into the equation. Very good. Now from here, we even know the value of a. This is not a again because already we know the value of a. A is what? 1. So multiplying 1. When x is equal to 2, then we are going to have 1 is equal to the a, which is 1 multiplying 1 plus, we have 2 squared plus b by 2 plus c multiplying what? 2. At the end of the day, we are going to get our equation to be 2b plus c. When you simplify the equation, minus 2 as equation 2. Now, if you solve the two equations simultaneously, then you are going to get your final answer for b to be, b is going to be equal to negative 1, and your c is going to be what? 0. And already we have a to be equal to 1, meaning our integration of 1 on x 1 plus x squared, where we express it, is going to be integral of a. A is 1 on x plus, now b, which is going to be negative 1 x. C is 0, so plus the 0 is also gone. Very good. Everything on 1 plus x squared, like this. So this, we can better integrate this. So integrating everything with respect to what? Dx. If we integrate the first part, which is integral of 1 on x dx, minus, we apply integration of 1 on 1 plus x squared dx. This part is going to give us, also when we, the derivative of x is going to be what? 1. So we still have the natural log of what? X. Minus, when you check this part, it is also the same thing as multiplying. If we find the derivative of this, we are going to get what? 2x. Is that true? Yes. So this part, this x is supposed to come. So we have 1 multiplying x this way. We are going to get 2x. So if we multiply both sides by 2, that means we are going to still have our 2 inside the x, and the answer is going to be half the natural log of what? 1 plus x squared. So at the end of the day, this is the integration answer for the right hand side. So we can now equate the two solutions, the left hand side and the right hand side. At the left hand side, our answer was half the natural log of 1 plus y squared equal to the right hand side, which is log of x minus half natural log of 1 plus x squared. That's our constant c. So this is our solution. Remember, this is log. We can still compress this equation. If you want to compress it further, now this is going to be natural log of 1 plus y squared. This half at the back will come here. Then I will send everything minus this to the other side of the equation of x. Then we can also say plus this part. Natural log of 1 plus x squared. Then the half will come here. Then still plus c is equal to 0. Are we okay? So still we can leave the answer in this form, but if you still want to compress further, then we can still have natural log of, now since these two they are subtracting, then the log is going to give us 1 plus y squared half on what? X. And the whole thing is also adding to this, so they are going to multiply this part, which is also 1 plus x squared raised to the power half. So this is our final solution. Let me equate everything to the constant c. So this is the solution for the problem. Are we okay? So let's look at the last example, and under the method of separation of variables. Let's look at the last example. Now, example 3. Let's solve the equation xy cubed dx plus e function of x dy is equal to 0. So we want to still use the method of separation of variables. So our solution, we rewrite our equation xy cubed dx plus e function of x dy is equal to 0. Now I still want to group all the x at one side and all the y at one side. This is what we are going to have. So I can divide through by this. So x is going to be ex like this. And I will divide through also by y cubed dy is equal to 0. Now if you are interested, you can send one of the variables to the left hand side, or you can work with them all at the same side of the equation. You understand? So I prefer to work this one. There are many ways to solve a question. That's why I'm repeating, or I'm just bringing in a new approach. So with this, we are solving them here. So now we can apply our integration. We can apply our integration. So inside the problem, let's have this as x squared. Let's make it quite complex. So x squared this way, such that this one is also going to be with x squared. Alright, this will make it interesting. So we now have it this way. We can get this side or rewrite the equation as x e. Now I'm trying to bring the e part, so it is going to be negative x squared dx plus the y2 is going to be y negative 3 dy is equal to 0. So let me apply my integration this way. I want to solve or integrate them one after the other. So let me first, from this part of the integration, which is the integral of x e negative x squared. Yeah, I want to integrate only this. So I'm going to use the method of substitution. What we are going to do is we are going to let our u be equal to negative x squared, where our du, if we differentiate this, we are going to get negative 2x. So making the x the subject, we are going to get the x is equal to du on negative 2x this way. Very good. Alright. We can bring it inside the equation where we are going to have our integral of x e minus x squared is going to be equal to, this is still the x. Integral, we still have our x. Now, this is going to be e, because we've let u be that to be equal to u. Now, what is dx? Dx is what? U on negative 2x this way. Very good. Yes. So now this x can take care of this, right? And that is going to give us negative half or integral of u du. This is what we have. Now we can integrate this. If you integrate this, you are still going to have half of what? Au plus our constants, where u now is also going to be equal to half negative e negative what? X squared. So this is the integration for the first part. What about the second part? Now integral of y negative 3 y. This is very simple. We are going to have y negative 2 on negative 2 plus c. Very good. So if we are now combining everything, then our final answer is going to be negative half a negative x squared minus y negative 2 on 2 plus our constant is equal to 0. Very good. Yes. So we can multiply through by what? 2 such that we have our negative ax squared negative y negative 2 is equal to our constant c. This is our final solution. This solution can also be simplified as we will multiply through by one negative, giving us e negative x squared plus 1 on y squared can also be this equal to c. This is also a simplified version of a solution. Alright, thank you for watching this episode. This is method of separation of variables in solving a differential equation. Check out for the next episode. Please subscribe, like, and share the video. See you in the next episode.